I'm going to explain about 16 to 4 encoder. So encoder means it converts 2 power n input lines are converted into n output lines. So for example, if you take 4, n value is 4, 2 power 4 2, that is 4 output lines are there. 2 power 4 means that is 16 input lines, input data lines are converted into 4 output data lines. And one more definition for encoder is, so it converts one form to another form. So one form of data is converted into another data lines is called as, that is encoder. I will show you one thing, one example. If you take 1010 is a 4-bit binary data, I am assuming. So this is converted into 2-bit binary data for some reasons, either security or else bandwidth reasons. It will convert it into, that is just assume that this is N0. 10. So means it is an encoded data. That is 1010 is converted into 10. So this is an encoded data, encoder. So again, if you want decode the original data, if you want, again we need to decode. That is 10 is again decoded into 1010. This is an original form and also named as, that is decoded data or decoder. So this is the decoded data. So coming to the that is 16-bit data or 16 to 4 uh, encoder. So we can say this, it is having 16 data lines, input data lines, and it is having 4 output data lines. That is, we can assume anything, either D0, D1, D2 like that, D0, D1, D2 and D3, or else Y0, Y1, Y2, Y3. So here also you can assume anything, X1, X2, X6, or else Y1, Y2, Y3, like this. We can assume anything till Y15. So Y16, because it is initially it is Y1 to Y16. So 16 data lines are converted into that is 4 output data lines is called as 16 to 4 encoder. So I will show you one thing. So I am assuming here, so this is an data input lines, 16 input lines are converted into 4 output lines encoded data. So I am assuming this is the first position. I am assuming this is I am assuming A1, A1, I am assuming, or else A0. A0, A1, this is A1, and A2, A3 like this, and till 15. This is A15, this is A15. So 15. So here we can say this. This is the encoded data. That is the input data. So this data, input data is that is A0 is 1 and remaining all inputs are zeros is encoded into 000. Encoded. This is an encoded data 000. And again this is A1 is 1 and remaining all are zeros and is encoded into, assume that this is the first position. This is an this is the first position. This is the 0 position. Assume this is 1 and this is 1 and this is the second 2 value equivalent to 0. This is the first position and I am assuming this is the second position. I am assuming this is the third position, fourth position, fifth position, sixth position. Like this we can assume, or else here it is there already. So this encoded data, this input data, just assume it is the 0 1 means 2 value. Binary decimal equivalent is 2. So just assume it is a 2 value. So it is again, it is converted. This is first position. This is the first position converted into 0001. 0001. Again, we can say this. I'll show you here. This is, yes. So the second data we can say this. I'm assuming this is on A15 to, that is A0. A15 to A0. So this is first one is 1 and remaining all are zeros. A1, A2, A3 all are zeros. So all are zeros all are zeros. So this is, and this data is converted into, that is 0 0 0 0 0 0, and again 1, this is 1, and remaining all are zeros. This 16 data lines are encoded into 0 0 1. This is an encoded data, and again one more data I have, that is 0 0 0 1 0 0. So here you can till 15 lines we have. So again this is encoded into 0 1 0 0 1 0. So like this, the 16 possible data lines are converted into, that is 16 output encoded data. This is 1 1 1 zeros. Here 4 bits are there, so 0 0 0. So this is till 16 bits. It is converted into like this. This is an encoded data, and this is an encoded data, and this is an encoded data. And here we can see this the same thing. So this is an first encoded data, and this is an second encoded, third, and last one 15th encoded data. Coming to the logic diagram, I will show you one logic diagram. You can see this here. O0 means here O0 I want. So I will take Q0 or else O0. Anything you can O0 I will draw. I will show you here. So O0 output is equal to, you can see this O0 is 1 8 1 8. When it is, that is, this I am assuming A0, A1, A2 till A15. So O0 is 1 8 A1, and 1 8 A3, A1 A3, and 1 8 A1 A3, 1 8 A5, A5 is 1, A1 A3 A5, A1 A3 A1 plus A3 plus A5 A5 plus, again O0 is 1 8, O0 is 1 8 A7 plus, again A0 is 1 8 A9 plus, odd numbers, again A0 is 1 8 A9 A11, A means 10, B means 11, again like that, again 1 8 A13, 1 8 A15. So odd numbers are there. So therefore we can write like this the O0 equation: A5 A7 plus A9 plus A11 plus A13 plus A15. A15. Now we can draw easily uh, the logic diagram. A1, we required A3, of course A3 also required, A2, A3, A2, A3, A4, A5, A6, A7, A8, A9 up to A16, A9, A10, A10, A10 means A, A11, A12, A13, A15, A14, A15, A15. So now we can draw easily the logic diagram. So A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, A13, A15, A14 and A15. This is 14, A14 and A15. Now we can A1, A3 plus A2. I will take this is equal O0, first one. So I will take one OR gate, one OR gate, one OR gate, one OR gate equal to O0, A1. So A1 is here, A1 plus, I will draw it here, A1 plus, A1, A1, A1 plus, A3 plus, A3 plus, A5 plus, A5 plus, A7 plus, A7, A9 plus, A9, and A11 plus A11, A13 plus A15. So this is O0. So like this we can draw the remaining also, we can draw easily, that is O1, and we can draw easily, that is O2, and we can draw easily, that is O4 also, we can easily draw it. We can easily draw O4 also. So like this we can draw the logic diagram. So here you can see this, there are 16 input lines, data lines are converted into 4 output data lines, is called as 16 to 4 encoder. So this is about encoder. One form of code is converted into another form, is called as encoder, or else 2 power n input lines are converted into n output lines. If you have any doubts, please send to me, or any suggestions. Thank you.